Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the detection of an intrusion via the methods of signature-based algorithm and this anomaly detection algorithm. So how this algorithm when be a trade-off to the intrusion detection and which should be choose over which to get an actual and accurate detection of the intrusion that is even a successful or an attempted one. System securities and facilities are linked together to provide the intrusion detection. As its name suggests, it strives to detect an attempted or successful intrusion into the computer system. So to successfully detect a particular intrusion that is already attempted or have been caused an anomaly in that particular computer system, we have to follow the following steps. The time at which the intrusion has occurred, that is at the time of the intrusion being done or as it is an after effect. And what are the factors that were affecting this particular intrusion? That can be a simple input or can be a range of the addresses that are affecting by that particular intrusion detection. The range of that responsibilities of capabilities. The responsibility of capabilities is that the capabilities or the objects that are particularly straightforward to get intruded. Now this intruded of the system designer must specify that the intrusion software should be done very handled carefully. Now they may assign a honeyspot that is a false spot for the resourcer of this intrusion to get that a false idea that this is a resource for your attacking ID. Now the attacking ID is the honey spot which will derive to the intrusion detector that the intrusion cannot be done at a very easy level. So these three factors if recognized, then we can allocate any of the algorithms of the following to detect the intrusion that has happened. The first one is the signature-based algorithm. The signature-based detection algorithm allows us to make a signature or a specific input or a particular hardware process to identify that a particular intrusion has happened. And after that intrusion has happened, it should follow the specific pattern or the sequence of the intrusions to detect it when the next time it will be attempted to success. So in this way, signature-based allocation of the detection algorithm is occurred. Another type of algorithm that is occurred is an anomaly detection algorithm. In this way, first the computer system's behavior on every process's normal one is recognized. And then if there is any anomaly on that particular normal behavior of a function or a process, then it should be checked and there occurs an intrusion or not. Not in every case that an anomaly causes by the intrusion, sometimes the anomaly caused by the process itself. But all the intrusion causes an anomaly, that is why every anomaly should be checked against an intrusion has happened or not. So the main difference between this signature-based allocation of the IDS, that is the intrusion detection system, and intrusion prevention system or the IDPs, along with this anomaly detection algorithm is that the anomaly detection takes the normal operation and checks for the anomaly within it, and the selection of the signature-based algorithm first checks that there is any point of the characterized intrusion algorithm. If there is an intrusion, then it looks for that the dependence of that intrusion for prevention. Now for the anomaly detection algorithm, it generally characterizes all the normal operation of a process and then looks for the process if there is any anomaly in the behavior. If the normal behavior is different from this anomaly behavior, then it looks for an intrusion has occurred or not. In contrast, the signature-based allocation detection algorithm uses only the known intrusion that is got a sequence of patterns that is matched with the signatures or a simple input. So, it is generally used by the virus detection vendors algorithm designers, which is then used for the viruses which has a prescribed sequence that has been attacked on a computer system. Now the anomaly detection algorithm, as it takes all the normal behaviors as can be a way of to get in the intrusion. So all the anomalies are detected and then checked for an intrusion. So if there is not any anomaly or an anomaly is caused by only a process's problem, then it is marked as normal. And this benchmark should be given that a process is marked as normal for a normal anomaly or no anomaly, and if there is an anomaly for intrusion, it is marked as detected. And this benchmark is absolutely important because other than exceeding the giving of the false positive, that is the false alarms, and the false negative, that is a missed intrusion detection. So if they are not marked properly, then there should be some false alarms on the false positive and the intrusion that has been missed because they were not marked properly. Now we will consider an example that how this signature based detection is different from this anomaly detection of algorithm. So first it uses that for a system of 100 instructions that can be intruded on a system. So there are 2 or more instructions that can be done on per day intruded, and each record in the auditing of that particular instructions record millions of a recorded per day. Now that there is 10 records to detect a particular intrusion. So what is the probability of the intrusion that will not be a false positive and a false negative? That will be definitely an intrusion on that particular anomaly based on that anomaly detection algorithm. So here the formula is so that is the intrusion per day into records per institution divided by records that can be audited per day. So that will give us the idea that what is the probability that the anomaly is actually an intrusion. So it gives us the result of. Now suppose that A be an alarm for derived by this IDS on the intrusion detection algorithm by a signature based detection. So that PA on I is definitely 0.0002. Now on PA on not Y will be 1 minus PA on I, that is equals to. So that gives an alarm means an intrusion and no alarm means no intrusion. So to imply this one for an anomaly detection algorithm, we use the Bayes theorem. The Bayes theorem is as follows. So now consider the case of an false alarm rate. The false alarm rate specifies that is the PA on I on the rate of this PA of I. The PA on not I, that is a false alarm rate, will give us by this calculation that even if it is a good intrusion detection algorithm, so it will be near around 0.001. So that we can see. So even if 1 less than of 7 out of the alarms are only an intrusion. So it is very much inefficient. It's called a Christmas tree effect when this type of information happens, because it is giving us an false alarm and false negative exceeding in this anomaly detection algorithm. So that is the trade-off, that we cannot suspect an anomaly in a normal processes operation behavior. Rather than we go for the signature detection algorithm, we can specifically say us that there is an intrusion and we are detecting for that particular intrusion not to happen again. So that is all for the intrusion detection system. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.